Hello, equations. Sooner or later you will have to cope with some of them. So let's have a quick look at some of the typical techniques for equation solving. To start, let's take this simple equation. 2x minus 15 equals 9. The solution of this equation must be something like x equals a constant, where the constant is a number. But to achieve this, we have first of all to sort out all the components of this equation into two groups. The first group are the components containing the unknown x, and we will want to have this group on the left-hand side of the equation, so to the left of the equation mark. The second group are the constants, or components that do not contain the x, like negative 15 and 9. What we can notice is that two of those components, 2x and 9, are already in place. We have one component that is misplaced, negative 15. This component should be on the right-hand side of the equation because it's a constant value. We can achieve this by adding 15 to both sides of the equation. We have to add the same number to the left and to the right-hand side. If we do it for the left-hand side, we will get 2x minus 15 plus 15. The two 15s will cancel out, and we will get 2x. And the right-hand side will, of course, be 9 plus 15. So adding them together, we get 2x equals 24. We have sorted them out. We have unknowns on the left-hand side and constants on the right-hand side. With one exception, x is still multiplied by a number 2. So to get rid of this number 2 and get just the lone x on the left-hand side of this equation, we have to divide both sides by 2. So we get x, it's 2x divided by 2, so it's just x, equals 24 divided by 2, and the final step gives us the solution x equals 12. The equation is solved. Let's have a look at this example, which is a little bit more complex because, first of all, we have 4 different components here. So as previously, we will want to put all the unknowns, so 5y and negative 2y on one side, and constants like 5 and 40 on the other side. The first step will be to subtract 5 from both sides of the equation. In that case, in that way, we will get rid of this 5 component, effectively moving this component to the right side of the equation. So 5y plus 5 minus 5 is, of course, 5y, and the right-hand side is 40 minus 2y minus 5. The second step, or the second component which is still not in place, is negative 2y. We can get rid of them, of this one, by adding 2y to both sides, again to both sides of the equation. So the left-hand side is now 5y plus 2y, and the right-hand side is 40 minus 5. Adding together left and right side, 5y plus 2y is 7y, and the other side, 40 minus 5 is 35. The last final step is to divide both sides by 7, so that to get rid of the 7 from the left-hand side, 7y divided by 7 is y, and 35 divided by 7 is 5. Let's now revisit the first equation and make some very interesting observation. The goal is to put all the unknowns or components containing the unknown to the left side of the equation and all other components or constants to the right side of the equation. And we can rearrange this equation freely if only we follow one very important rule. If any component is to switch the sides, so go for example, from the left side to the right side, it has also to switch the sign. So from negative 15, it becomes positive 15. So once again, if a component remains on the same side of the equation, like 2x or like 9, it remains intact. But if we need to move the component across the equals sign from the left side to the right side or from the right side to the left side, the sign has to change from minus to plus or from plus to minus. Similarly, we did in the second equation. Here 5 was moved from the left to the right, and it switched from positive 5 to negative 5, and similarly negative 2y switched the side and became positive 2y. Let's try to solve another equation using this slightly, I think, simpler method. However, it is mathematically identical approach to the original that I showed previously. So let's just rewrite this equation, trying at the same time to rearrange various components. So 3x is already in place, nothing more to be done. 6 will be moved to the right, so we will just ignore it now. And from the right hand side, we handpick negative 2x, but because it has to change its side from the right to the left, it will also switch the sign, so negative 2x becomes positive 2x equals, and on the right hand side we have 21, it remains intact, but we have to rearrange 6 from the left side, and this positive 6 becomes negative 6. Isn't it simpler? So let's now add both sides together. 3x plus 2x is 5x equals 21 minus 6, it's 15. Divide both sides by 5, x equals 15 over 5, it equals 3. Solved. One more example is an equation which seemingly has two unknowns, but sometimes we need to solve an equation against a particular unknown, and in this case we will solve this equation against x. So this means that the solution of this equation should be x equals an expression that may involve y and constants. So in other words, we will consider any component containing the variable y as a known or as constant. So let's try to rearrange it, and you will see what I mean. So left side should contain components that have x in it, so 5x and x. But x changes its sign, so it will be 5x minus x. And everything else will be on the other side, so it's negative 2y plus 4. They don't change the sides, so they remain intact. And 6y becomes negative 6y, negative 20 becomes positive 20 because they switch the side. Now adding everything together, I mean left and right side separately, of course, 5x minus x is 4x, and the right hand side, negative 2 minus 6, it's minus 8, negative 8y plus 20 and 4, 24. So x equals negative 8y plus 24 over 4. We can decompose this fraction by separately dividing one and the other component. So we get x equals negative 2y plus 6. I will finish with one more example. It is mostly an algebraic expression representing a ratio or a proportion. Although quite simple, it is often confusing and misleading for students. This equation contains three symbols, A, B, and C. Finding b is reasonably straightforward. It involves multiplying both sides of this equation by 2c, and in this way we get b equals 2ac. In another step, we can divide both sides of this equation, the second equation, by a, getting 2c equals b over a. Please note that I swapped the sides of this equation. And in one more small step, dividing both sides by 2, I can get the value of the third symbol, c, equals b over 2a. If you solve this equation step by step as presented here, you will probably find it reasonably easy to calculate the value located in the denominator of this fraction. But quite often students try to guess the solution of this equation, getting a whole range of incorrect results, such as 2a over b, or a over 2b, or at least 2b over a. So instead of guessing, I suggest to solve this equation step by step, or alternatively, using a graphical form of solving this kind of equations. A proportion like this, a equals b over 2c, can be graphically represented by a triangular form in which we put the a in the lower left corner, and then the horizontal line inside the triangle symbolizes the fraction bar. So we have here b over 2c. The vertical line can represent multiplication. Now we have three different ways of reading the content of the triangle. B equals a to c, or a equals b over 2c, or finally 2c equals b over a. We can get these three equations instantly just by looking at this triangle. The final thing left is to look at the worksheet examples of 8 different equations, and as usually, I will give you 5 seconds. Please press pause in this video and try to solve these equations all by yourself before I reveal the solutions. And the solutions are Thank you for watching. It was the final video in Maths 101 series, but if you have any suggestions for future topics that we could discuss, don't hesitate to contact me.